Hello. Let's try to evaluate trigonometric functions using trigonometric identities. Okay, so before I give you your trigonometric functions, let's write down our trigonometric identities. Correct? So the trigonometric identities which we just derived are, let me write down here, sine squared theta plus cos squared theta equals to 1. That is one identity. Second is tan square theta plus 1 equals to secant square theta, and then we have cotangent square theta plus 1 equals to cosecant square theta. So we'll use these identities and we'll try to evaluate some trigonometric functions. Okay, so let me give you some here. So we'll start with this one. We have 5 cot square x minus 5 cosecant square x. We want to evaluate this. So cot square x and cosecant square x are related like this, right? So from here we can write cot square x minus cosecant square x will be how much? So 1 will go, that will be minus 1. So first we can take 5 common, so this is equal to 5 common, and we get cot square x minus cosecant square x, right? Now from our identity we can either write cosecant square x as cot square theta x plus 1. So when we write that, we get minus 1 here, or this is the identity, and so we can rearrange the identity. Once you rearrange in this form, we get cot square theta and bring it here minus cosecant square theta equals to 1. So for x also it is the same thing. So this inside thing is equals to minus 1, right? So I can write this as cot square theta minus cosecant square theta equals to, and take this one here as minus 1. So I'm replacing this with minus 1, and so I get minus 5 here. So like this, you see how we rearranged and got our answer, correct? Let me take one more example, do it in a different thing this time. Let's say we have 7 secant square theta minus 7 tan square theta equals to what? So it's same thing, like secant square theta is here, so we take tan square theta on the other side, right? So it becomes secant square theta minus tan square theta, which is 1, right? So we can, first we factor out 7, and we get secant square theta minus tan square theta, and that's the identity which can be rearranged. And we know secant square theta minus tan square theta is 1, so this is equal to 1 times 7, right? So it is 7 times 1, which is 7. Is that okay? So like this you can rearrange and write your identities and evaluate the expression. Okay, so that's what we mean by evaluating an function using the identities. Okay, now you can try something like let me give you one problem here for you to try. So let's have this problem as sine square x times cot square x times secant square x. Okay, you can try evaluate this kind of an expression, right, and see what you get, right? So follow the same strategy. So what you can do is, in this case we will not use these identities which I mentioned here, but what you can do is, you know about reciprocal identities, and let me add those identities for you. Basically, you know what is tan theta equals to. Tan theta is equals to sine theta over cos theta, correct? So this is one of our basic identity, correct? The other basic identities are the reciprocal identity. correct? The reciprocal identities are, you know, that secant theta is equals to 1 over cos theta, correct? And cosecant theta is equals to 1 over sin theta. And cot theta equals to 1 over tan theta, correct? And tan theta, as you know, is sin theta over cos theta. So this forms a set of identities which we call basic trigonometric identities, okay? And these three which I have listed first, they are also called Pythagorean identities, Pythagorean trigonometric identities, because we derive them from a right angle triangle with Pythagorean theorem, which is a square plus b square is equals to c square, where c is the hypotenuse of the right angle triangle, okay? So try this question using these identities on your left, okay? Thank you.